Okay, so we were doing reaction kinetics. I told you that what is the rate of reaction? Rate of reaction is the change in concentration per unit time. Change in concentration is given in moles per dm cube upon time. Time is in seconds. Therefore, the units for rate would be what? Mole per dm cube per second. Now, I also defined the rate determining step, rate mechanism, and order of reaction. What is rate mechanism? Most chemical reactions, they happen in multiple steps, so they have a mechanism. Those multiple steps, when you add them up, gives you the overall reaction. So the sequence of steps is called the mechanism, and when you add them, you get the overall reaction. In that mechanism, you have different steps which have different rate, and the slowest step is called the rate determining step. Why is it called the rate determining step? Because from the slow step or the rate determining step, you can derive the rate equation. What is the rate equation? It is directly proportional to the concentration of the reactants in the rate determining step raised to the power of their molar coefficient. I also defined the order of reaction. What is the order of reaction? It is the power to which the concentration of a reactant is raised in the rate equation. Do you see right here it is raised to the power 2? So this would be second order. It is raised to the power 0 would be 0 order. Order can be 0 order, first order, or second order. You are also sometimes asked to determine the overall order of a reaction. And how do you do that? By adding all the orders. So for this example right here, if they ask you the overall order, how will you calculate the overall order? It will be the order of this reactant, which is second, plus the order of this reactant, which is 0. So 2 plus 0, the overall order will be second order. Clear? Then I also told you how to determine the units of K. Since rate is directly proportional to the concentration, you can remove the proportionality sign and equate that with K, which becomes the rate constant. Rate constant is a fixed value at a given temperature. If you change the temperature, the value of K will change. Then we have the units of K. How do you determine the units of K? Rate is equals to K. Let's take the same example that we were doing. NO2 square, carbon monoxide raised to the power 0. What are the units of rate? Rate is mole per dm cube per second is equals to K. What is K? K is what we need to find. NO2 square. Since this is the concentration, this will be mole per dm cube square, and this will be mole per dm cube raised to the power 0, which will be 0. So you bring these units of mole per dm cube square down here, and you derive the units of K, which come out to be mole minus 1 dm cube per second. Let's see another example. You have this question right here, where the overall equation is given to you, which is 2NO2 plus F2, giving 2FNO2. This is the overall equation. They've given you the 2 steps of the reaction as well, and they've told you that the first one is the slow step, and the second one is the fast step. Which step will be the rate determining step? The slow step. So can we call this the rate determining step? Because the slow step is the rate determining step, and we will use this step to find the rate equation. Yeah. Now they're saying determine the overall order, the units of K, and the rate equation. So let's solve this and let's see how we determine the rate equation first. Rate is directly proportional, I told you, to the concentration of the reactants in the slow step. So what are the reactants in the slow step? NO2. So rate will be directly proportional to the concentration of NO2 and F2. What are their molar coefficients? For both, the molar coefficient is 1. So it will be raised to the power 1. You don't necessarily have to show the 1. Now you can remove the proportionality sign, and when you do that, you will get what? The rate constant, which is K. So this becomes rate is equals to K, NO2 raised to the power 1 and F2 raised to the power 1. This right here becomes your rate equation. Do you see? The rate equation is derived from what? It is derived from the rate determining step or the slow step. How? Rate is directly proportional to the concentration of the reactants in the slow step. Clear? Let's now move on to the next part. They are saying, find the overall order. So if you see right here, what is the order with respect to NO2? Can we say rate is first order with respect to the concentration of NO2? Because what is order? Order is the power to which the concentration of the reactant is raised in the rate equation. And also, can we say rate is first order with respect to F2? If you need the overall order, how will we calculate the overall order? The overall order would be the sum of the individual orders. So the overall order would be first order plus first order, and therefore the overall order would be second order. Clear? Moving on to the next part, they say you got to calculate the units of K. So let's see how we will do that. So we have our overall equation or the rate equation, which is rate is equals to K, NO2 and F2 concentration. What are the units of rate? Rate is moles per dm cube per second. Equals to K, that is what we need to find. What is the units for concentration of NO2? It would be mole per dm cube. What is the concentration of F2? Also mole per dm cube. Now, you need to find the units of K. So you take these two right here and you will divide them there. So this would become mole per dm cube per second divided by mole per dm cube and another mole per dm cube. And all of this will be equals to K. Now, if you see in the numerator, you have 1 mole per dm cube. In the denominator, you have 2 moles per dm cube. So can I simplify that and cancel 1 with the 1 in the denominator? And you will be left with 1 in the denominator, which you can take in the numerator. And this would become what? Mole minus 1 dm cube per second. These are your unit. This is your SI unit for K. Clear? So we found the units for K. We found the rate equation. And we know the overall order, which is second order. Is this clear? Is this clear? All right. Now let's try these. All right. Calculate the overall order of the reaction in units of K for the following. So let's see. The overall order would be second order. Yes, because there is only one of these reactants raised to the power 2. So the overall order will be second order. Let's find the units of K. How will we do that? So this is mole per dm cube per second. Rate is mole per dm cube per second. We don't know K. And this would be what? Mole per dm cube squared. Because the concentration is squared, so the units will also be squared. And then you take this to the denominator right here. And when you do that, this becomes mole per dm cube. You take it to the denominator, so this becomes mole per dm cube square in the denominator. Now you have 1 mole per dm cube in the numerator and 2 in the denominator. So you can cancel the 1 in the numerator with 1 in the denominator. And you will be left with 1 in the denominator. And when you bring that to the top, the units of K become what? Mole minus 1 dm cube per second. Let's see B. What will be the overall order? The overall order here would also be second order, because this is raised to the power 1, raised to the power 1. The individual orders are 1 for each reactant. You add the 2 and you get second order. Let's see the units. The units would be mole per dm cube per second divided by mole per dm cube for this and mole per dm cube for this. So that's again mole per dm cube square. Now you have 2 in the denominator, 1 in the numerator, so you cancel this out and your units of K again become mole minus 1 dm cube per second. Clear? Clear? Part C, rate is equals to K, A square, B square. Let's see the overall order for this. So what will be the overall order? 2 plus 2, that would be fourth order. Let's see the units of K. It would be mole per dm cube per second divided by mole per dm cube square for this and mole per dm cube square for this. So a total of how many mole per dm cubes? 4. So you have 4 in the denominator, 1 in the numerator. So you cancel this out and you'll be left with 3 in the denominator. You bring it to the top and the units of K become mole 3, mole minus 3, dm9 per second. Clear? For D, let's see the overall order. What will be the overall order? Overall order would be first order plus 0 order. That would be second order. Let's see the units. The units will again be mole per dm cube per second divided by mole per dm cube squared. So when you solve for K, what are the units of K? It comes out to be mole minus 1 dm cube per second. Clear? Yeah, do you all get it? Moving on to the next question. Determine the rate equation and the overall order for the following. Rate is proportional to X. So they say rate is directly proportional to concentration of X and not affected by Y. So if it is not affected by Y, then Y would be what? 0 order, because it is not affected by Y. And now when you remove the proportionality sign, you will have the rate constant. So rate is equals to Kx y raised to the power 0. This right here becomes your rate equation. And if you want to calculate the overall order would be what? 1 plus 0, that is first order. Because this is first order, this is 0 order. So the overall order would be 1 plus 0, that is first order. Clear? Rate is proportional to square of y and w. So rate is proportional to square of y and square of w. So let's see. When we remove the proportionality sign, we will have the rate constant. It will be y square and w square. What will be your overall order? The overall order will be second order plus second order. That would be 2 plus 2, and that is fourth order. Clear? Rate is proportional to square of x. So it is proportional to x square, not affected by z. That means z would be raised to the power 0. And proportional to y. So that must be raised to the power 1. You remove the proportionality sign and you get the rate constant k, x raised to the power 2, y raised to the power 1, and z raised to the power 0. This becomes your rate equation. What will be the overall order? The overall order will be 2 plus 1 plus 0. That is third order. Is that clear? Now, what is the order of reaction? I told you order of reaction is the power to which the concentration of a reactant is raised to in the rate equation. Now, order of reaction can be first, can be 0, first, or second order. Very rarely is it third order. So individual order with respect to each reactant. So order with respect to each reactant can be 0, first, or second. Overall order can be third or fourth, but individual orders can only be 0, first, or second. Very rarely third. Yes? Now, you can determine the order by graphs also. So your order can be determined graphically. And this can be determined by looking at two graphs. So it can be determined by two types of graphs. And let's see those two types of graphs. So which graphs can give you the order? The first one is rate against reactant concentration graph. So you can have rate against reactant concentration. And the second graph is reactant concentration against time. So you have two types of graphs which can give you the order of reaction. One graph is the rate against concentration, and the other is concentration against time. We will see these graphs individually for 0, first, and second order. We will see both of these graphs individually for each order, and you'll see how, by looking at the graphs, you can determine the rate. You can determine the order. All right. So you can have two types of graphs, rate against concentration of the reactant and concentration against time graph. We can also determine the order by the rate equation, which we have done. So order can also be determined using the rate equation, which we have seen before. So let's see an example of that. For example, if I tell you rate is directly proportional to a square, b, and c raised to the power 0. Can you determine the individual orders by looking at this rate equation? Yes. How? You can say rate is second order with respect to concentration of A, because you see it is raised to the power 2. So we can call this second order with respect to A. Likewise, we can say rate is first order with respect to concentration of B, because you see it is raised to the power 1. And likewise, we can say rate is zero order with respect to concentration of C. If they ask you the overall order here, what will be the overall order? It will be the sum of all the individual orders. So it will be 2 plus 1 plus 0, and the overall order of this reaction is third order. Is this clear? Any questions? No? Now,